3.3. Using virtual environments to create a stable and isolated work area. The venv tool sets up a work area with a private package library and a specific Python version. We're going to see how to use venv and pip to set up a work area, and we're going to see how to activate and work in the work area once it's been set up. When we're working on a project, we'd usually like the parts of the project that aren't our own code to stay the same. We might have a good reason to install a new version of Python or an updated library on our system, but we don't really want those changes to happen within our development environment. Even more so, we can easily find ourselves targeting entirely different and incompatible system configurations with different projects. We need a way to set aside an area for each project that is separate and can be configured for the specific needs of that project. That's what we call a virtual environment, and the venv tool that's built into Python version 3.3 and later creates them for us. Each virtual environment created by venv knows which version of Python it should be using and has its own package library, which means that, as far as Python code is concerned, it's basically disconnected from the rest of the system. We can install, uninstall, and update packages on the system, and code inside the virtual environment won't even notice. We can install new versions of Python, and the code inside the virtual environment won't even notice. About the only thing we can't safely do at the system level is uninstalling the version of Python that the virtual environment is based on. It's easy to create a virtual environment for a new project. We just open the command line and go to the folder where we want the project folder to reside. Then we use the version of Python that we want the virtual environment to use to run the venv tool and tell it the name that we want to give to the project folder. The venv tool will create the project folder and populate it with the files needed to support the virtual environment. When we actually want to work inside the virtual environment, we should activate it. To do that, we open the command line and go to the folder containing the virtual environment, then execute the activation command. The specific activation command depends on the operating system we're using. On most Unix-style systems, including Macintosh, we use the command source bin/activate. On Windows, we run the scripts/activate.bat file. When we're operating inside an activated virtual environment, pip automatically knows it should manage packages for that environment. Initially, the virtual environment contains only the standard Python library and a couple of utilities, including pip. But we can use pip to install the third-party packages that we're going to use on the project. They will automatically go into the virtual environments library. Now that everything's set up, we can begin to work. We shouldn't delete any of the files or folders that venv created, but other than that, we're free to create files and folders as needed for our project. A virtual environment keeps our project's underpinnings stable. The Python version and installed libraries remain the same for the life of the project. A virtual environment is created from the command line with python-m venv. Inside of a virtual environment, pip installs to the private package library automatically, so there's no need for --user or any similar switch. Now that we've seen all that, we're going to take a closer look at docstrings. In the next video, we'll learn how to structure our docstrings for maximum utility, how to add rich text formatting to them, and how to export them into hyperlinked HTML documentation for viewing in a web browser.